You just hooked a 500-pound marlin. The reel screams, your arms burn, and the battle is on. This is no time for equipment failure. Every second counts.
I'm Pat Courtney with JTEKT, and we're going to talk about drawn cup, needle roller, clutch, and clutch bearings. So what is a clutch? So a clutch is a device that locks on the shaft in one direction and then is able to spin freely in the opposite direction. So think of a pull start for like a lawnmower. So when you pull start, it's engaging that blade, so it's locking, and then when you let go, the blade continues to spin, so it's obviously the bearing or the clutch there is allowed to spin freely. So think of a fishing reel. Where a fishing reel, it locks in one direction, and then some fishing reels will actually spin freely in the opposite direction. Or there might be two clutches positioned opposite each other, so you can lock it in one direction, and then actually use your fishing reel and spin it the opposite direction, and it locks in the reverse direction. So that's what a clutch does. Drawn cup needle roller clutch is basically the same as a drawn cup needle roller, or is basically designed and manufactured the same way. So these are going to be a drawn cup, which is we take a flat sheet of steel, we draw it into a cup, and then once that cup is formed, it's a finished part. Once we draw it into that shape. Now, what's cool about that drawing process is we can actually draw these little ramps that are inside this cup. And those ramps are what the rollers will ride up or down to lock that shaft in place or to spin freely. So what's also inside these clutches is a cage which also acts as a spring. So what happens inside of a clutch or a clutch bearing, those rollers, the spring will push those rollers up the ramp and take all the clearance out of the bearing. When all the clearance is taken out, so those rollers will be basically pushed up against the shaft, then it locks to the shaft. Then when it goes in the opposite direction, the spring allows those rollers to go back down the ramp, and now you have clearance inside the bearing, and so then it just spins freely on the shaft. So those internal ramps are actually drawn into the part, so we don't machine those on. Those are actually made during that drawn cut process. No machining or grinding. High volume multi-stage presses, which translates into typically a lower cost. Now, just like the other drawn cup parts, these are case carburized, which means that we use a low carbon steel. When we heat treat it, we introduce carbon in the atmosphere, and that's what makes the surfaces hard. So when we think of a clutch, a needle bearing clutch or a needle bearing clutch bearing, it's very similar to a drawn cup bearing. It's got the same drawn cup, it's got needle rollers in it. The needle rollers are made out of 52-100. It's basically like a cage style type drawn cup needle roller bearing. Now that cage, like I described before, it acts as a spring as well, and we have two different types of cages. They're both made out of plastic, but they're different colors. And that cage acts as a spring. One is all one material. It's a black material. It's going to act as a spring and as a clutch, or as a spring and a cage. The other is an orange material, and it's going to have like a stainless steel bar inside there, and that stainless steel bar is what's pushing against that roller. That's the spring. And there's a big difference between the two different designs. For the polymer spring, which the one where there's no stainless steel, that one can see up to 200 degrees in temperature, 200 degrees Fahrenheit. It can also engage 200 times per minute. So what's an engagement? Well, an engagement is that locking motion. So I can lock this shaft. It can reload itself 200 times per minute. So if I needed to index that shaft very quickly, with that polymer type spring, I can engage that 200 times. Think of like a copier or printing machine where it's spitting out the paper. It can do that 200 times per minute. Now the stainless steel spring, it can see up to 250 degrees Fahrenheit, but it can see 6,000 engagements per minute. So 6,000, so it's much higher. So what's going to see 6,000 engagements per minute? If you've ever been to a casino and you've seen those automatic shuffling machines where the dealer puts all these decks of cards into this big machine, and then all of a sudden these cards just spit out and they're automatically shuffled. that machine has got those clutches in it, and it's, again, engaging those cards, and it's moving those at a very high engagement rate. So 2 types of clutches. One is just the clutch. So the clutch, when I look at, most of the product line is relatively small. Well, we're going to touch on that in a second. But so the clutch has one set of rollers, and it's not designed to take any radial load. It's only designed to take torque. And so what is torque? Torque is the ability to twist this shaft. That's torque. But we're not going to put a load on this shaft. We're just going to twist it. Okay, so, and if you look inside, I don't know if the camera can show it, but you'll see there's only one set of rollers. Okay, so now with a clutch bearing, what that clutch bearing can do, it can take torque just like a regular clutch, so it locks in one direction, spins freely, but then it also has 2 additional roller sets. So it has a set of rollers at the top, another set here, and then you have a larger set of rollers in the middle. The set of rollers in the middle are your clutch. The 2 sets of rollers on either end will be able to take a radial load, and that's why we call it a clutch bearing. So the clutch is not a bearing. It's only designed for torque. Okay, so the clutch bearing has obviously those 2 extra set of rollers, and that's capable of taking a radial load and a torque. Now, just like a drawn cup needle roller bearing, no thrust loads. So no thrust loads. What's the size range? It doesn't have a very wide size range, anywhere from an 1/8 of an inch bore, so very small, to about a 1-inch bore. So that's on the inch side. On the metric side, we go from 4mm bore to a 36mm bore. So very similar inch and metric as far as the general size, but not a very big product offering. So why don't we go bigger? Why don't we go larger? It's the ramps. So the way we draw those ramps, you can't do that without starting to machine those ramps. And so there are larger types of ball bearing clutches that actually machine those ramps in there, but they can see obviously higher torques. Again, like a drawn cup, no integral in a ring. So if it has to ride on the shaft itself, in this case a pin, but that shaft will have to be machined and ground. It'll have to be heat treated, just like a drawn cup bearing. So those needle rollers have to have a surface that they can ride on that's hard and smooth. So it has to be ground and it has to be heat treated. Now, if you can, just like with drawn cup, we have an inner ring that can be pressed onto that shaft for all of our clutch sizes. So if you can't get that, we have a specific inner ring part that you can purchase that'll go onto that shaft. Now, just like a drawn cup, it's pressed into the housing, so it's a press fit because it's not round. So again, a regular drawn cup, this part is not round in the free state. So when we take it out of the box, if I measure the ODs, it's not going to measure a round part. It's going to get round by pressing it into a housing. And it's going to have a press fit in the housing, which means that the OD of this part is going to be smaller than the hole that it's getting pressed into. So I can't push it in with just my hand. I will need a special press to push that bearing into that housing bore, because the OD of this bearing is actually going to be bigger than the hole. So I got to squeeze that, I got to force that bearing, and it's going to round up this clutch or bearing into a round shape. So you got to press. Now, just like the drawn cup, you got to make sure that you press on the stamped side, which is the side with the part number. And I don't know if the camera can catch it because these part numbers are really small, but the stamped side is going to have the part number on it. What you'll also notice is the stamped side, the unstamped side, it's got kind of more of a round edge, and the stamped side is flat. So you're always going to want to be pushing on that flat side to install it. And these typically do not have seals, but they usually are pre-lubricated. So we like a certain type of grease that's going to ensure that those rollers engage properly. So a lot of times these will be pre-lubricated. So why use a drawn cup, needle roller clutch, or a needle roller clutch bearing? Thin cross-section, again, very thin cross-section, high torque. Now again, high torque relative to the amount of cross-section. So again, this isn't a torque device for something that's going to have to generate a tremendous amount of torque. When we look at the amount of torque it's going to need to generate, we look at a fishing reel. We look at an exercise bike. We look at a rower. Okay, so different applications, obviously not huge amounts of torque. Again, used in very tight spaces. The nice thing about the clutch bearing, it can also handle radial loads. So instead of having to put in a separate bearing, you can actually get the clutch bearing, and you can actually take the torque and the loading. Very high engagement rates. So like those money counting machines, paper copiers, high-speed copiers. Again, excellent product to be able to handle those high engagement rates. And it's relatively inexpensive. Again, these are made on high volume presses. So not a lot of material, high volume presses, lower cost. Installation is simple. So where is the drawn cup needle roller clutch product used? Again, commercial printers, money counting machines, ATM machines. So every ATM machine has our clutches in it. So if you've ever used an ATM machine, put your credit card in. What you have is you have two shafts, two rollers, one above, one below. The card goes between. The clutch engages on the top roller, and it grabs your card. And then when the card spits back out, the roller on the bottom engages. And this one spins freely, and it pushes your card out. So that's your ATM machine. So every ATM machine has clutches on it. So one big point I want to make is you do not use these for safety critical applications. So in summary, high torque capacity to a thin cross-section ratio, available as a radial needle bearing as well, so you can get the radial load as well as the torque. Typically low cost, not a large product offering, easy installation, good for light-duty commercial and consumer products, and again, not for use in safety critical type applications. I hope you enjoyed this peek into drawn cup needle roller clutches and clutch bearings. Yes, when the pressure's on, these things deliver a truly clutch performance. No slipping, no stalling, just smooth, one-way motion. Stay tuned for more bearing training from JTEKT, formerly known as Koyo.